Okay, so let's quickly just go over how to create a single dimensional integer array, and we would do something like this, pointer, like this. So this would create a single variable in memory at some address, and an undefined value. So then, okay, let's give it a value by allocating some memory for it using the new keyword, and we will give it size 3. Okay, so this will create a block of memory of size 3. The integer, yeah, the integer, the type of it doesn't really matter, but it tells the compiler what's the size of this piece of memory that we are allocating. In case of integer, it's just 4 bytes, but it could be an object or anything like that, and the same thing would happen, except that each index in the array would be a little bit bigger depending on the size of the object. Okay, so that would now allocate that memory at some position in memory, and assign it the value of that, the first index, the first address of that array to the pointer, so like that. Okay, so let's so we've created allocated new memory, and a good thing is, so always when you allocate memory, think about who is going to delete that memory and where. So in this case, we would just have the memory deleted at the end of this function or whatever we're busy with, like this. But that's not really a very safe way to delete it, because maybe that pointer is pointing somewhere that shouldn't or something like that. So a better way is just to check that that pointer is actually pointing to a valid piece of memory, which means it's not null. Okay, and then also set that pointer after you've deleted it to null, so that it will give a clear error when you try to access or do anything with that pointer after it's been deallocated. Okay, so now we've made sure that we don't have any memory leaks. Let's start to assign some values to the indexes in the array. So the normal way, or the easy way we would do that, is by just assigning a value to the first index, like this, and in memory we would then get the value over there. Another way we could access that index is with just the pointer and no array brackets or whatever, by dereferencing the array like this. So star array, which means that take the value of that pointer array, which is 800 in this case, and then get the value of that at that address. So at address 800, that value. So this would be equal to 35 at this stage. We could also then assign a value to that index like this. So if we do this, oops, we would then get in memory the value like that. Okay, so that basically is how you would handle a single dimensional array. Now a two-dimensional array is basically just a one-dimensional array of pointers to another another one-dimensional array of values, or a set of them. So to declare it, you would have something double pointer, oops, like this, which will create once again a value in memory at some location with an unknown value. Okay. we'd create an we would allocate memory with a new keyword for a bunch of memory, which is just pointers, not integers, pointers of a certain size, 2 in this case, which will then once again in somewhere in memory create a memory block to allow for that size, which is in this case an integer but a pointer with not a known value, and assign it the first address in that block, so 300. Okay, but now we haven't assigned any values, which just allocated the memory. But first, let's think about where are we going to delete it. So we're going to delete it at the end of program. First check, is it a valid pointer? And then delete it. And set it to null. Okay, now we can go ahead and allocate more memory for the second set of pointers that we've now created here in this allocation statement to another set of array of integers. So array of integers. If we use the normal array index method, we would go like this, and now just an integer. Let's have size 2 as well, and that would now once again create this at some point in memory, no value or undefined value actually, and once again set it over here. Okay, so once again we've allocated memory, so think about where are we going to delete this. And most of the time with an array you would write a for loop to go through each of those indexes and delete the memory that was allocated for it. So it would look something like this, smaller than the size, whatever that is, and then you delete it. Wait, let's clean that up a bit. It's basically just a normal delete of an array like that, and you could set that pointer to 0 because it's basically like this, but since we already know the next step, we are going to delete take away the pointer to that array, and no one will be able to reference that again. It's not really necessary. Okay, but that's so we've taken care of the memory, no memory leaks, and we've created another array of integers this time, and now we can go and assign values to that index. Something like this, which, you guessed it, in memory would look like this. Okay, so now a different way to do that again with the pointers is to dereference that, which will then give us this one over here, and then we go ahead and dereference it again, which is then 800, and that'll give us the value over here, which is 35. So let's try and change that now to 40, and we would get 40 over there. This is interesting because you can see how you can now start to expand on that. If we wanted to get the next memory address over there, we would dereference it again to get to the second array, and then we can go ahead and and then add 1. So then it's 800 plus 1 dereference, which give us then we can assign the value, which will then put that over there. So this is a bit intricate way to say basically the same thing as you would say there, with that being a 1 or something like that. but you can see that it basically this is just an abstraction of what is happening over here, because you have a pointer pointing to another pointer pointing to the actual value that you want, and you just increment or decrement it a bit to offset it by some value to get to the nth index in that array. So this is basically the way all higher dimensional arrays will work. You would just dereference more pointers as you add more levels to it. So to declare a 3-dimensional array, you would get 3 stars. Your first array that you will do is then a pointer to a pointer, still so adding one more pointer, and then you would allocate more memory, and it will be another pointer, and you would insert another allocation again to give you more memory. In this case, then it will be just an integer, and you would also have to think about deleting it, so you have a for loop in a for loop or something like that, deleting the values. So we would also then delete the memory for the outer array. Oh, I forgot to add that. You have to give the index over there for the outer one then also, and then you can eventually delete it. So you just add more and more loops to make sure that you delete all the memory you've allocated, and yeah, so that's basically 3D pointers. So now that you have a clear understanding of how single-dimensional and two-dimensional arrays work, I leave it to you to try and figure out how you apply this knowledge of the pointers pointing to other arrays of pointers to figure out how a 3-dimensional array would be referenced and allocated and deallocated. Also use the Valgrind application to test that you have successfully removed all your memory leaks. Thanks for watching, and see you next week.